It's time for another amazing chemistry video with Mr. Stapleton. Grab this one, sit back, I'm doing a nice coffee. Hi guys, welcome to this video, which is just an introduction to the Chatelier's principle. Okay, and just a brief introduction to talk about, I guess, what it is and what an equilibrium is and what or why Le Chatelier came up with this principle. So the principle of Le Chatelier is that a system at equilibrium will remain in that state unless acted upon by an unbalanced force. Now, basically what that means is that a system will move to counteract any change imposed upon it. Okay, so really the key thing that you want to be remembering, the key word you want to use when you're talking about this is counteract. Okay, so the equilibrium, you want to talk about if the equilibrium shifts to the left or the right. Okay, so what I've got here, alright, is I've just got a couple of things. Hopefully I can just show you a bit visually what's actually happening. So what we've got here is, I'm just using the coloured markers, 2 black plus 1 blue. Okay, so we haven't put the 1 in front of it, but just because the stoichiometric values are important though. So 2 black plus 1 blue gives us 2 red. So in reality, there's 2 equations actually happening here. Okay, so what's actually happening is we have some black like this, 2 black like this. We're adding a blue, okay, and we end up with 2 red. So that's what we call the forward reaction. Okay, and there's also a back reaction that's occurring, and that's actually where we take 2 red, okay, and that forms 1 blue and 2 black, okay, and that's what we call the back reaction. Alright, so we have both a forward and a back reaction in any equilibrium. Okay, the equilibrium arrows are used to signify that the reaction goes both forwards and backwards. Now, it doesn't necessarily mean that they're equal. You can always have one side favoured more than the other. And there are a lot of things that can determine about which side is favoured. So you can look at concentration, temperature, pressure, all these sorts of things can impact upon which side of the equation the equilibrium lies. Okay, but if you can understand that each equilibrium has both a forward and a back reaction, okay, that'll be a good start for you. So what we're going to be talking about is what happens when you introduce a change to a reaction. Okay, so I'm just going to rub these out. Okay, and what I'm going to do is we're going to just talk about a system. Okay, so if we imagine that this reaction here happens within a closed system, okay, which is also very important for equilibrium. Okay, that means that nothing can go in and nothing comes out. So initially what we do, alright, is we put in some black. Okay, so we put some black in and we put some blue in initially, a bit like this. Okay, and over time what happens is that starts to react. Okay, so the black and the blue combine together. Okay, it starts to create some red. Okay, so we start to get all these red forming from it. We then get to some reaction of red going back to form black and blue. Okay, and this keeps going back and forth until the reaction reaches a point where it's happy. Okay, and the concentrations do not change. Once we've reached this point where the concentrations do not change and there's no further change to the system, we've reached what's called a dynamic equilibrium. Okay. Now what that means is that the rate of reaction forward is the same as the rate backwards, so that means that we don't have any change to the concentration of our species within here, and there's no change in the macroscopic properties. So that means when we're looking at this, we don't see anything change, even though what's happening is we've got 2 red, okay, reacting to form a blue and 2 black, okay, and we've also got 2 black and a blue reacting to form more red as well. Okay, so this is kind of the principle of equilibrium. We've got these forward and back reactions occurring. Now, Le Chatelier's principle says that if we change the conditions or change something within the equilibrium system, it's going to want to shift to counteract that change. So let's say, for example, that what we did was we brought in more blue. Now, I'm sorry that these aren't the same size, and don't worry about that. But what you can see now is that we've got more blue within our system. Now the equilibrium doesn't like that, right? That's upset the equilibrium, and so it's going to shift to counteract that change. So because we've brought in more blue, the equilibrium is going to shift to get rid of the blue. Alright, so in this case what we're saying is the equilibrium is going to shift to the right, okay, to try and decrease this blue that we've put in. So the Chatelier's principle states that we shift to counteract the change. So to get rid of this blue, what we need to do is we need to have blue reacting with black, okay, and that will get rid of the blue. So if we take these blue out, we'll take this one out, okay, it's going to react with 2 black, okay. What that's going to do is that's going to form 2 red. Now what's happened is that the equilibrium has shifted towards the right. You can see now we've got more red here, okay, and it did that in order to decrease the concentration of the blue, okay, and we get to this point now where the system is happy again and we establish a new equilibrium. Okay, so that's basically what the Chatelier's principle is. Alright, a system or an equilibrium will shift to counteract any change imposed upon it. So that means it will, in this case, it shifted to the right to decrease the concentration of blue. Okay, if we started adding more red in, like this, okay, the system would be unhappy. It would shift to counteract that change. It does that by using up red or getting rid of red to form more blue and black. So what we would do, we take out some of this red, okay, every time we take out 2 red there, we're going to put 1 blue and 2 black in, like that. Alright, we keep to the mole ratio of the equation. And what's happening, alright, is that we again get back to a point where the system is now stable, we've established a new equilibrium. So I've got a couple of videos which I've done looking at the effect of concentration, the effect of pressure and the effect of temperature on an equilibrium, and looking at if it drives it to the right or to the left depending upon what the reaction is. Okay, so if you can just get into your head an understanding about that every equilibrium involves a forward and a back reaction, okay, and that when you change an equilibrium the system will shift to counteract that change. That's the Chatelier's principle. Then you'll have a really good understanding to be able to answer some of the questions that involve temperature, concentration and pressure. Alright, hopefully this has been a good little introduction for you. As always, go back over it, have a look at it, ask me if you've got any questions. Thanks guys.